let's look at two problems that we can use solving the law of sines. First off, notice that here we happen to know an angle, the next angle, and this side. So we might call this angle, angle, side. Some people would go the other way and they might call it side, angle, angle. But either way, if you have two angles, you can always find the third angle. That's what I would go for first. So alpha is going to be 180 degrees minus this 48 degrees minus this 52 degrees. Notice that this is definitely not drawn to scale. So 180 minus 52 minus 48 equals 80. Once I have 80 degrees, then I'm going to look for a pair, a side and angle pair that I know. So sine of 48 degrees over 5.3, and then a side angle pair where I don't know something. So here I don't happen to know C, but I do know that this angle is 52. Okay, so how am I going to solve for C? I'm going to cross multiply. So C sine 48 degrees equals 5.3 sine 52 degrees. Then I'm going to divide by this. So C equals 5.3 sine of 52 degrees over sine of 48 degrees. Okay, that's something that's fairly easy to punch in. So first off, just make sure that you are in degrees on your calculator. That's on the mode button. I'll press enter, then I'll quit. Okay, so now that I'm in degrees, 5.3 times sine of 52 divided by sine of 48. You can see that this side C is going to be approximately 5.62, or it might tell you to round to the nearest tenth, in which case this side would be 5.6. Okay, now can you see that this side is slightly smaller? So, sorry, this angle is slightly smaller. So this side is slightly shorter than this side. That makes sense. Last thing to do is to figure out A. So I'll use the same pair I know. Sine 48 degrees over 5.3 equals sine of 80 degrees over A. Okay. Similarly, I'm going to cross multiply and then I'll divide by that. I get A equals 5.3 times sine 80. If you want to write the sine 48 over there, you can, but in the next step it'll come over here. Then we're going to punch that in. 5.3 times sine 80 divided by sine 48 gives us something approximately 7.0. So that's solving that triangle. Now notice this triangle has a slightly different setup. This triangle we have angle, side, angle. So angle, side, angle, or if you want to go counterclockwise, angle, side, angle as well. Again, if you have two angles, I'm going to go for the next angle first. So alpha equals 180 minus 48 minus 52. I've cheated a little bit and given myself the same calculation as above. Shockingly, that comes out to 80 degrees. But of course, here's where the similarities end, because this side length is something I didn't have in the last problem. So what are we going to do now? I'm going to take an angle side pair that I know. So sine of 80 over 4.9 equals sine of 52 over C. Right? Now I'm going to cross multiply so that I get C sine 80. Getting a little sloppy about leaving off my degree signs. That comes with the territory, I'm afraid. Sine 52 degrees. Now simplifying, getting the c on a side by itself, I'm going to divide both sides by sine 80. So 4.9 times sine 52 degrees over sine 80 degrees. We'll go ahead and punch that into the calculator. 4.9 times sine 52 divided by sine 80. So this side c will be approximately 3.9. One side left to go. How am I going to get this side? Well, I'll take sine 80 over 4.9 equals sine 48 over b. Solving for b gives me b equals 4.9 sine 48 degrees over sine 80 degrees. So now I just have to calculate that in. 4.9 times sine 48 divided by sine 80 gives me 3.7-ish. So there's a couple of examples of using the law of sines to solve triangles.